Fault is a right lateral strike-slip fault located on a transform plate boundary in the East Bay of California. This means the two tectonic plates the Hayward Fault lies on, the Pacific and North American plate, move against each other horizontally when an earthquake occurs, with the right plate moving towards the observer. It potentially affects the communities of San Jose, Oakland, San Leandro, and Berkeley, just to name a few. The Hayward Fault lies beneath more than 300 structures in the East Bay, some of which are part of UC Berkeley's campus. As a UC Berkeley student, we are inclined to care about the Hayward Fault and its possible dangers for our own safety during our time here. Major earthquakes have been documented on the Hayward Fault to display a pattern of a major earthquake every 150 years, plus or minus 60 years in between. The last major earthquake that occurred on the Hayward Fault was in 1868, about 150 years ago, meaning the next major earthquake on the Hayward Fault is due any time now. The Hayward Fault interacts with UC Berkeley's campus in many ways, some of which I will be investigating today. The first place I went to was the Hearst Mining Building on campus, one of the buildings that has been affected by the fault and retrofitted for it. The visible gap between the buildings demonstrates how the Hayward Fault has altered the structure of UC Berkeley buildings through its movement. Another visible effect of the Hayward Fault on Berkeley's campus is the offset of Strawberry Creek. Strawberry Creek has a 335-meter offset due to the fault's right lateral horizontal movement. One of Berkeley's on-campus housings, the Foothill Dormitories, is built directly on top of the Hayward Fault line and has been built to withstand the shaking of an earthquake. As Professor Bergman explained, one feature of Foothill that was built specifically to withstand the earthquake is the bridge, which does not connect to the main building so as to not deteriorate the building's structure in case of an earthquake. But perhaps the most well-known interaction between UC Berkeley and the Hayward Fault is Memorial Stadium, which is also built directly on the Hayward Fault line. Memorial Stadium has been retrofitted to sit on two separate concrete slabs to withstand an earthquake. There's also evidence within Memorial Stadium that proves the Hayward Fault is an aseismic creeping fault. This demonstrates constant movement along the fault rather than it being locked in place, with the GPS proving a 4mm creep per year. In other places in Berkeley, the creep can be observed by breaks in the sidewalk or other structures, such as the Hearst Mining Building we already explored earlier. So what will happen when the earthquake actually occurs? To prepare for the next Hayward Fault earthquake, we turn to the Hayward scenario, which illustrates a hypothetical event of the highly anticipated earthquake. The Hayward scenario describes the effects of a potential 7-point magnitude main shock earthquake along the Hayward Fault. Aftershocks of the earthquake could occur during a 2-year time period after the initial main shock. Liquefaction, which is when soils become a liquid-like consistency, and landslides are two definite effects of the aftershocks of the next Hayward Fault earthquake. Preparation for the next major earthquake along the Hayward Fault integrates aspects of social sciences, engineering, and earth science to prevent social and economic consequences, improve infrastructure, and increase earthquake preparedness. At least $25 billion and up to $50 billion have been invested in counteracting future Hayward Fault earthquakes. The Hayward Fault presents the East Bay and UC Berkeley with many dangers, but as we have been taught, with ample preparation and knowledge, we can reduce the severity of its effects.